Hi, my name is Emily, and today we're going to be talking about the white nose syndrome. The white nose syndrome is a disease that is affecting bats all across North America, and it is caused by an invasive fungus, Pseudogymnoascus destructans, or PD for short. Since its emergence in 2006, the white nose syndrome has killed over 7 million bats. And because of this, researchers are calling it one of the most destructive wildlife diseases in modern times.
So, why should we care about this? Well, bats are really important. They consume vast amounts of insects that damage our agriculture. They also help to pollinate flowers. And they disperse many seeds of bananas, mangoes, and agave, and many more.
In this video, we will be talking about how the bat's inflammatory immune response might be hurting the bat's survival. But before we can understand how a fungus can kill a hibernating bat, we first have to know how a healthy body responds to a fungal pathogen.
So, you've probably heard of white blood cells that live in our body and work to fight infections, but there are many different types. One of them is called the macrophage. Macrophages fight infections by engulfing pathogens and producing inflammatory signals called cytokines. There's also the neutrophil, which is like the tough guy as it contains many cytotoxic chemicals. We also have the helper T cell, which helps the others. We are now ready to understand how our bodies normally respond to fungal pathogens. The first barrier to infection is our skin. Just like how the first barrier to people breaking into your homes would be to shut the doors and windows to keep them out. If an invader breaks that physical barrier and is able to enter, that's when it's our immune system's job to kick in. Macrophages patrol around looking for something that shouldn't be there, just like a friendly neighborhood police. Once it recognizes a breach, the macrophages and the police will do their best to capture the invader and call for additional help. Instead of using eyes to find suspicious activity, macrophages will use receptors called TLRs. Macrophages then produce a signaling molecule called cytokines to recruit other immune cells to help them clear the invader, similar to how a police might use a walkie-talkie to call for help. These cytokines then travel to the blood vessel, where they make the blood vessels dilate to allow for other white blood cells to be able to come through. Neutrophils will come in and release their cytotoxic chemicals to destroy the pathogens. Helper T cells also produce signaling molecules. All of these effects together help eliminate the fungal pathogen.
Luckily, healthy animals don't have to worry about fungal pathogens because these tiny cops have our backs. But if our immune system becomes weakened, then we can be in big trouble. Now, people can become immunocompromised in a number of ways, from getting other diseases to getting chemotherapy to even getting a lack of sleep. But other animals can get their immune systems shut down when they go into hibernation.
Animals go into hibernation in the winter to save energy when there's not much food available. Hibernation shuts down many bodily functions, including the immune system. Similar to if your phone were on low battery, you would probably want to turn the brightness down, stop using anything that wasn't essential, and even power it down. Hibernating animals do the same thing. Their temperatures and metabolisms drop, and they try to use as little energy as possible.
So, how does hibernation impact the immune system?
During hibernation, the number of white blood cells decreases by about 90%. Also, phagocytotic capacity goes down, meaning immune cells can't engulf pathogens as well. The cytokine production also decreases. White blood cells also struggle to proliferate. Antigen production decreases, and this is just to name a few. All of this increases the risk of infection.
So, what's going on with the bat's immune system when they're infected with PD?
When the bats are infected with the fungus that causes white nose syndrome, researchers at Bucknell University in 2015 found that the processes that lead to inflammation still do occur. Macrophages are still able to recognize the fungus, and they also still produce cytokines. Those cytokines are still able to travel to the blood vessels. where they still punch holes to make way for the white blood cells to enter. But because the bats are in energy efficiency mode, the neutrophils and T cells do not come to help the macrophages. To make up for it, the macrophages keep sending out more and more cytokines, desperately calling for help as they can't handle the invader by themselves. This causes more and more inflammation, which is irritating to the bats and disrupts them while they're hibernating. This disruption causes them to wake up very frequently and use up all their energy sources, which results in them dying due to starvation.
So most of this research is very, very recent, and our understanding of what's going on will likely change. However, it is important to do this research to figure out how our immune system interacts with different pathogens. Because the more we know, the closer we get to understanding how to stop outbreaks like this one. Thank you very much for watching, and I hope you enjoyed.